Alright, the last topic that we need to go through is dealing with logarithms and exponentials. And we didn't touch any of this during advanced algebra, but we did cover this back during the Algebra 2 days near the end of the year. So this shouldn't be completely new, but the main parts that we're going to talk about definitely become quite important in terms of remembering how to solve some of these problems. So let's get right into it. First, knowing what a logarithm is. A logarithm is just kind of a inverse of an exponential equation. We read this as log base 6 of 36 equals 2. Okay? And here's how I'm going to look at it. I'm going to call this B-A-E. Yes, Bay. Okay? Base, answer, exponent. What that means is I can rewrite it as base to the exponent equals the answer. 6 squared equals 36, which obviously it does. And number 2, first off, I don't have a base. Well, what is our normal base that we always live in? Well, we count in terms of tens. Base 10. That means we write it as BAE, 10 to the 4th equals 10,000. For the third one, base to the exponent, so 3 to the negative third equals 1 over 27. Which it definitely does. Remember, 3 to the third power is 27. The negative means you flip the fraction. Don't forget that. That's really huge for our problems in calc. So in this one, again, BAE, 4 to the x power equals 64. Well, let's figure out what would x have to be. Well, x, 4 to what power gives you 64? That'd be 4 cubed. In this one, 5 to the x power equals 1. Well, 5 to what power gives you 1? Well, anything to the 0th power always gives you 1. So that's the main part to remember there. Anything to the 0th power always gives you 1. Now this one, ln. What the heck is ln? Well, ln is just a fancy way of saying log base e. And e, I kind of mentioned this earlier, e is just some random number. It's like 2.71. Kind of like pi, it goes on forever and ever. It just becomes a very natural number. That's why we call it ln, the log natural, the natural log. So, if I rewrote this, this would be e to the x equals e to the 4th power. Well, what does x have to be to make this equal? Well, the bases are the same, the exponent's got to be the same. So that means x would have to equal 4 in that case. Alright, now, these last problems are all problems you should be able to solve without the use of a calculator. And here's what I mean by that. For number 1, you have 3 to something and 3 to the something. The bases are the exact same. If the bases are the same, that means the exponent's got to be the same. So I'm just going to set the exponents equal to each other and solve for x. So subtract x from both sides, add 70 to both sides, and divide by 2. So 33 will be your answer for x. Okay, for number 2. In this case, though, we have 4 to the something and 8 to the something. The bases are not the same. Well, here's how I solve this. Is there some number out there that I can raise to a power and get 4, raise to another power and get 8? Well, yes, there is. That number is 2. 2 squared is what gives me 4. 2 cubed is what gives me 8. And I just write everything else as is. So now, what I have here, if I have a power to a power, I multiply those exponents. So what this means is I now have 2 to the 2x minus 2 and 2 to the 3x plus 3 when I multiply those exponents together. Now I do have the same base, so now I can solve it just like I did in number 1. So 2x minus 2 equals 3x plus 3. Subtract 2x from both sides. Subtract 3 from both sides. Negative 5 is your answer for x. And number 3, again, I don't have the same base. But what I can see here, though, is that I have e to some power equals 1. Well, anything to the 0th power equals 1. That just means my exponent has to equal 0. So that means 2x minus 7 equals 0. That means x will equal 7 divided by 2. 2x will equal 7. 7 divided by 2. Alright, logarithms work kind of the same way. Number 4 is like the exact same as number 1. I have 2 logarithms with the same base. If those logs are the same, that means the parts on the inside must also be the same. So I'm just going to set x plus 2 is equal to x squared plus 2x. I have a quadratic. To solve a quadratic, I bring everything onto the same side of the equal sign. So I'll subtract an x and a 2 from both sides. gives me 0 equals x squared plus x minus 2, which I can factor that to be x plus 2, x minus 1. So that means I set both of those equal to 0, giving me x equals negative 2 and positive 1 as my answers. In number 5, log base 9 of x minus 7 equals 0. I'm going to rewrite this as an exponential. Remember, BAE. So 9 to the 0th power equals x minus 7. Well, what is 9 to the 0th power? 9 to the 0th power is just 1. So that means this becomes 1 equals x minus 7. Add 7 to both sides, gives you x equals 8. And number 6, e to some power equals 0. When can you have an exponential ever equal 0? You can't. This does not exist. This cannot possibly happen. Because you're always, when you have a number, raise it to a power, you're always going to get a positive number. And number 7 is also no solution. Because remember, if we talked about our graphs, you can never take a logarithm of a negative number. If you wanted to try to rewrite this, this would be like saying e to the x power equals negative 3. How can a power ever equal a negative number? It never can. And number 8, very similar to number 2. There should be a number that I can raise to a power and get 5, raise to a different power and get 25. Well, that number is just 5. So this is just still 5 to the x plus 7. This would be 5 squared to the 2x minus 1. So this is still 5 to the x plus 7. This now becomes, I multiply the exponents. So it would be 4x minus 2. Now I can set the exponents equal to each other. X plus 7 equals 4x minus 2. Add 2 to both sides and subtract x from both sides will give me 9 equals 3x, which means x equals 3 as my answer. Okay, so again, the main thing to notice in doing all these algebraically is especially knowing how to switch back and forth using the using your Bay method, and also recognizing that exponentials must always be positive, and you can never take the logarithm of a negative number. There you have it, logs and exponentials, and you guys are pretty much done for the summer.